Hi everyone, in this video we're going to talk about the properties of rhombi. That's just the plural of the word rhombus. So a rhombus is a type of quadrilateral. It is a type of parallelogram too, and depending on what curriculum your state follows, some states also consider a rhombus to be a type of trapezoid. That would mean it inherits all of the properties of those shapes. So for example, in a parallelogram, the opposite sides are parallel. So that's true for a rhombus then, because a rhombus is a type of parallelogram. But there are a few unique properties to a rhombus. That's all sides are congruent to one another. The diagonals are perpendicular, so let's examine what that would mean. So if I draw in the diagonals, that means that they form 90-degree angles. That's what it means if line segments are perpendicular. So in here, in the center, we would get 90-degree angles. All right, we also have this other fact that diagonals bisect the angles. I'm going to just zoom back in here. Sorry to show you what that looks like. When we have the initial quadrilateral, the initial rhombus, there's 4 angles. Each one is now bisected by the diagonals. So that is split in half. This one is split in half. Since opposite angles are congruent, that's a parallelogram property that a rhombus inherits, it's basically going to be the same idea on the bottom here. One key thing that we're going to talk about in this video is that when the diagonals are perpendicular, really what you are getting are these little right triangles in here. And that means different facts about right triangles are now eligible to be used. So for instance, Pythagorean theorem being a way to find missing sides is going to be a common idea when you're looking at a rhombus. All right, so let's take a look at some questions. All right, number 1, the diagonals of a rhombus are congruent. We have to decide if that's true or false. That is false. Okay, that was not one of the properties listed above. Number 2, the consecutive sides of a rhombus are perpendicular. That's also false. That would mean that the sides form 90-degree angles. That's not true. If I wanted to make this a true statement, I would be changing this to say the diagonals are perpendicular. Okay, number 3. If one side of a rhombus is 6, find its perimeter. Well, this should be pretty easy, and we don't even need a picture for it. All sides of a rhombus are equal. So 6 plus 6 plus 6 plus 6 is 24, in this case, centimeters. Okay, number 4. In rhombus ABCD, if the measure of angle DAE is 52 degrees, find the measure of angle ADE. Well, remember that we talked about before that the diagonals are perpendicular, meaning you get these 90-degree angles in here. And then this goes back to just a fact about triangles. The angles in a triangle have a sum of 180 degrees. So we have 90 and 52. That gives me a sum of 142. I'm using my calculator here on the right if you want to follow along with my work. Subtract 142 from 180, and that makes this missing angle 38 degrees. All right, number 5. In rhombus PQRS, ST is 8, PT is 15. We're going to find the length of PS. So I mentioned before that these right triangles and right angles are going to be key because I'm looking for now basically the hypotenuse of a right triangle. The way we could do that is by using Pythagorean theorem. Now, if you know your Pythagorean triples, you might already know what the answer is, but I'm going to just go ahead and show all the work for it anyway. So I'm going to get 289 is equal to c squared. When I take the square root of both sides, I get 17 is c. So basically, PS is equal to 17. Number 6, in rhombus ABCD, angle A is 110 degrees. Find the measure of angle ADB. When we take a look at this, so we're going to go back to another triangle property. So even though we're talking about quadrilaterals, a lot of the properties then are really going to be old. So this is talking about in an isosceles triangle, the base angles are congruent. Those are basically the angles that are opposite the congruent sides. So if I take 110 and subtract it from 180, I get 70 degrees. Divide that by 2 because there's 2 angles here. So 35 degrees. So the measure of angle ADB is 35. Number 7, if PR is 14, SQ is 10, find the perimeter in simplest radical form. All right, so PR is that whole big diagonal, but we know that the diagonals bisect each other. We know that because a rhombus is a type of parallelogram, and that's a property of a parallelogram. So instead of labeling PR as 14, I'm going to do it 7 and 7. Instead of labeling SQ as 10, I'm going to do 5 and 5. And once again, reminder that we've got these right angles in the middle, and that means we have right triangles. So if we want to find the perimeter of the rhombus, we have to at least know what the sides are. So let's, just like before, do Pythagorean theorem. So 5 squared plus 7 squared equals c squared. That's going to give me 74 equals c squared. And when I take the square root of both sides, I get radical 74. So all sides are radical 74. We know that because all sides of a rhombus are equal. And when we add that up, we have radical 74 plus radical 74 plus radical 74 plus one more radical 74. And we are going to get 4 radical 74. Now, when you're doing simplest radical form, you want to just check to see if there are any perfect squares that go into 74. So for instance, like 74, is it divisible by, I'll just pick one that is not right here, 49, by 49? Nope, not divisible by 49. Is it divisible by 36? No. 25, right? I'm just trying different perfect squares to see if there's some way for me to simplify this. It's divisible by 9, no again, by 4. And you can see that I'm not getting another integer value. So there's no way for me to take radical 74 and simplify it further. So my answer is just simply 4 radical 74. All right, number 8, in ABCD, DAE is 4x plus 4. I'm going to squeeze that in here. And ADE is 7x minus 2. Find the measure of angle DAE. Reminder, once again, there's our 90-degree angle in the middle. That is very much a key fact for a rhombus. And here's a right triangle. Okay, well, what do we know about triangles? Their angles add up to 180. So 4x plus 4 plus 7x minus 2 plus 90 equals 180. You could have also just chosen to add those other two angles up to 90. That would also work. All right, when we combine like terms here, so 4x and 7x gives me 11x. So that's me combining these. Then if I combine 4, negative 2, and 90, I get 92 equals 180. All right, we're going to subtract 92 on both sides. So I get 11x is equal to 88. And I have x is 8. All right, we were asked to find the measure of angle DAE. And that was 4x plus 4. So 4 times 8 plus 4. And that will give me 36 degrees. All right, our last problem in this video is a coordinate proof. For this, I'm going to just get the calculator out of the way. And I start every coordinate proof by plotting the points. So A is 2, 6. I'm going to make sure I put A and label the vertice. Then I have 6, 8 for B, 10, 6, and 6, 4. All right, then I'm going to connect this, and we want this to look like a rhombus, so just check your picture, make sure that it looks like a rhombus. If not, go back and check that you plotted everything correctly. All right, we have to prove this is a rhombus, so we have to think about what is a fact that we've learned that is unique to a rhombus. And there's a few of them, but there's one in particular I'm going to show here, and one main fact, which is that all the sides of a rhombus are congruent. So if I can show that, and I mean, I'm going to show that AB and BC and CD and DA are all congruent, then this has to be a rhombus, because a rhombus is a quadrilateral that has all equal sides. The way we would show sides are congruent is by using the distance formula. So it's the big radical the change in x's squared plus a change in y squared. So for AB, when I subtract the x's, I get 4. When I subtract the y's, I get 2. And if I simplify that, I'm going to get radical 20. I'm not going to actually take the square root. I'm just going to leave it like that. Then I'm going to do the same thing for CB. Subtract the x's, I get 4. Subtract the y's, I get negative 2. That won't make a difference that it's a negative 2 because we're going to square it and we'll still get radical 20. All right, for CD, subtract the x's, negative 4. Subtract the y's, negative 2. Sure enough, radical 20. And then for DA, when I subtract the x's, I get negative 4. When I subtract the y's, I get 2. Radical 20. Okay. So remember, this problem is not asking, is it a rhombus? It is one. We just have to kind of like show the math behind it to verify. So I'm going to now just write a sentence putting this all together. So I'm going to say quadrilateral ABCD is a rhombus because all sides are congruent. So again, it's not asking us if it's a rhombus. It is one. We just have to verify it. That's why all of our calculations worked out. If you, for instance, got, radical 20, radical 20, radical 20, and radical, let's say, 16, you would know to check that last calculation. They should work out. Again, it's not a question here if it's a rhombus. It is one. We just have to verify it. So hopefully this video helps you learn a little bit more about the properties of rhombi. The rest of the videos in this playlist will cover the other quadrilaterals.